with no further ado, I think I will introduce the work that we've been doing as part of the Pistoia Alliance around what we call the Pharma General Ontology, but mostly trying to basically experiment with the LinkML stack to deliver the outcome of this meeting. So I was supposed to present, well, we got Birgit in the room, a coworker from Pfizer. I was supposed to also do the presentation with Josh Valdez from Novo Nordisk, but he had a delay, so he sent his apologies. So I will be standing in for the full show. So as I said, we will not be focusing necessarily on the ontology, but more on the experience with the LinkML stack so far today. But before starting this, I will like a couple of words on the Pistoia Alliance, which is an organization which brings together a number of industry companies around the topic of various activities, but the one in particular interest is that of verification. And this is the main topic that we will be talking about for you today. And this is the outcome of a project which lives in the context of an entire operation, essentially. The main challenge that we want to address is just to agree on a set of key concepts that are used in the R&D space to make sure that people can specify a set of vocabularies that they use in the context of data exchange. Put it shortly, we want to make sure that people provide URIs to the data value sets that they are using so that we have clarity and drop the ambiguity that is usually associated with strings when we try to exchange information across companies. So this is really an aspect of interoperability challenge that we are all facing. And this work started about a couple of years ago and is involving a number of pharma companies that you can see in the logos. Won't cite them all, but you can get a picture. So basically, this is a clear need that has been identified, and we are wrestling with this challenge. So also, this work is not done in isolation. So this slide introduces a number of streams that are at the heart of the activities carried out by the Pistoia Alliance. We are on this aspect on the left-hand side of the slide, which is about delivering data-driven value at scale. And there are a number of semantic resources that are being developed by the organization through collaboration between pharma and industry partners. And you can see there are 4 major efforts at the moment. IDMPO, which is more about medicinal products and compounds. Then we have efforts on clinical operation. Also something around an effort around chemistry and manufacturing control. But what we are mostly interested in at the moment is what we call the Pharma General Ontology, which is identify key concepts around early science, well, R&D aspect. I will get back on that. But we also, the Pistoia Alliance has a number of initiatives as well around the use of large language models, entity recognition, but also aspect of sustainability and the use of a number of new technologies in the field. I won't spend too much time on this, but this is more the kind of what is at the heart of the effort at the moment. If we look at the way the data can be exchanged between partners, either industry partners, 2 different companies willing to exchange data, or for each of these individual companies going to a contract research organization, each of them has to specify what we call possibly a data contract. But usually this contract lacks specificity, and this costs a lot of money for data integration, data reconciliation, and mostly the concept of data repatriation, when you need to recover the data from your CRO and obtain and push that into your pipeline. So every company has to do a deal separately, and I think the idea that we have is to produce something that it would be a kind of common profile of metadata that could be defined for a number of concepts that would serve the basis for creating those data contracts in a more machine actionable form. And this is hence the concept of associating to each concept and the value sets that would be allowed a number of uniform resource identifier for those elements, and therefore how do we specify that formally. So the idea is the analogy of the building blocks. We've seen this analogy many times, so I won't dwell too much on it, but this is somehow the elements. And the key bit here is that the Lego bits the connectors should be these identifiers that allow you to ping resources on map unambiguously and have clarity about what you are manipulating. I indicated earlier on in the presentation that, of course, we are at a stage we are focusing on R&D space. We are not specifying whether it's early science or late science, but that's what we are currently exploring. So how do we tie up concepts, metadata profiles, but also and value sets, so control vocabularies that could be maintained outside, but which provide the value sets for your contract. This is an important aspect. And bear in mind that this pattern of operation could be obviously, if successful, propagated to the rest of the organizations, and we could apply the similar patterns in sales, commercial, dividend, and other corporate functions, which would benefit from the pattern, and therefore propagating the notion of fair and the culture change around how data is managed in organizations such as large pharma industries. So giving you more details now about the use cases that are driving the effort, we have a specific document. And here we're highlighting a few of the, we'll leave you time to read through that, but I think one of the one that is currently driving mostly our work is that of the data repatriation and data transfer. So keep that in mind, but of course there are other interesting potential use case, and probably one of the most promising as well are any work related to making data submission easier and in a machine actionable form. But this is the scope of a different activity, but related, and I will get back to that later in the presentation. So in a way, now the elephant in the room, to some extent, since we are in a place of art and beauty, I think we can use this reference that from Magritte, that PGO is not really an ontology. I mean, for the proper semantic guys, we are mostly looking in this particular work on how to structure metadata. And as I mentioned LinkML at the beginning of the presentation, this is the crux. Sorry, here, yes. So this is to place the kind of concept that we have identified that are relevant for the task at hand and placed in the context of other efforts in the Pistoia Alliance work. So you can see we have these 20 concepts more or less, and they can be connected to other elements of the ontology that we have. So from clinical operations, but also control and chemistry and manufacturing and control. They are touching points. And the key aspect is, again, testing the methodology, building a community around potential patterns and technologies that we are testing so that we can increase the interoperability and the practice around the elements. So when it comes to the process of developing PGO, as I said, we started about a couple of years ago, and I think it's a big engine, big machinery. We need to get agreement from the different companies that are making up. So we need to also distill and mature the reasoning and drive the use cases. So we had the input from many experts working together, providing guidance from the industry, the needs as well, to refine the different components. Sorry, but I think this is also in this last few months, the maturing of the use case, the consolidation of our vision around the need to get a more technical footing on this one, and producing first set of machine actionable schemas for each of the entities that we have defined. And ideally, we would like to release this in a kind of open platform, open source way. So part of the activity at the moment is taking place under PGO, and we are testing the use of LinkML for that purpose. I assume that the audience is familiar with the LinkML platform. I don't want to delve too much into that topic. But in a way, in our work, we carried out a survey of the reality that interoperability means. We have data coming from the academic world, which is annotated with a number of resources that are well established. For instance, the OboFoundry resources at the core. We can obviously all know gene ontology, but a number of resources like from the human phenotype ontology as well, which are used on a daily basis for clinical application and which are essential to the work. But also we have the other end of the spectrum on the industry side, where we need to deal with regulatory deposition, and we have different constraints where the formats, standard developing organizations such as HR7 FHIR format for exchange of the data is really getting traction to the point that the regulator may require this information, but also we have for clinical trial data all the CDISC stack. So how do we bridge these two worlds that need to talk together? Is an interesting aspect. So this is where I think from the initial requirements that we had to provide a kind of machine actionable way of specifying information in a structured way, which embeds also semantic resources, is where the LinkML stack, both the model, the meta model, but also all the supporting software comes into play and has very interesting properties. And of course, we cannot not talk about LinkML without talking about an application, which was the BioLink. We've got the chance to have Deepak Uni in the room. So this is again the kind of baseground state-of-the-art survey that we have been carrying out for application of the PGO and what could be done. And it touches on an interesting aspect of FAIR principle as well, which is about interoperability and reuse. We cannot all the time develop new models. Interoperability starts by reusing components, be it models, but also a stack of software. And how do you do that? So I think there are a number of features about a LinkML schema or pattern that are really appealing from the open source stack, which means that you can contribute. It presents a number of challenges when you're working in industry, but I will touch back on this one. There is the aspect of schema-driven language, which is YAML-based, which is a bit more easier when we have to deal with business users. And we have the ability to embed natively and produce FAIR by design by starting with the schema, capturing the information requirement from the users and having all the markup from ontology, defining value sets and resources. I will go back on this in more detail in the next slides. So if you're not familiar, I hope you can see that well enough in the back or in the upstairs thing. But this is a different section of the LinkML schema. This is the declarative aspect where we identify all the namespaces that you want to use. You also can provide the license. So this kind of housekeeping metadata that you would like to always embed into your schemas. Also, there are interesting aspects about the import that you can do from other resources. So obviously, yesterday you probably have followed the excellent SPHN tutorials when the notion of schema forge comes to mind. So this is again the similar idea, I guess, that can be harnessed in terms of reuse and composability of the aspects. Here is another aspect where we have a schema definition. We look at type here that is being defined, and we've got pay attention to the class URI, for instance, which allows you to specify exactly what resource, and you make a choice here, but it's upfront and ambiguous, and you have to think about it carefully from day one. And then you have possible the identification of class mapping as well, which is built into the stack. And again, interestingly, in that schema, taken from the LinkML documentation, you've got already a FHIR mapping, which again provide connectors with things already. So you can also benefit from the mapping from communities and the work that exists. Reuse, this is something that is really important, and so you've got evidence of that here. And then what is interesting for the PGO aspect, I mentioned at the beginning of the presentation that we wanted to identify the key entities and possibly their properties when defining a contract, which allows us to have this negotiation and discussion about what kind of metadata we want to capture. But this aspect covers the kind of value sets and sources of information for the value sets that you are actually talking about. Here, this is an example from the BioLink, which specifies a number of resources, but this is up to you in your implementation when in your local companies or CRO or whatever operation you're in, you can absolutely explicitly define what you want to use. And this is already, if you think about exchanging data, moving data from one place to the next, a very important aspect in the data management that you can have. So I think this is the patterns that we would like to propagate and play with. And we have started doing our due diligence, reviewing from the 20 concepts that we have identified, where we have a hit on BioLink model, where we can reuse it off the shelf, or we need to adapt or adjust or refine. We already have identified a couple of gaps. These gaps are interesting because some of them, like target and biomarker, are worth a semantic ontology expert discussion of several months, I presume. But these are just the kind of things that we are experimenting with. The other aspect that we did with the LinkML evaluation, obviously we studied the schema, but we also tested the toolkit. And this is where the platform shines. There is a wealth of development. It's a very active community. And there are potential also aspect of contribution which are really interesting. Also, we have identified a number of gaps. So don't have time to dwell too much on those elements, but this is also a potential important aspect to consider when we think about adoption, understanding how community can contribute back. And here it's too bad that Josh could not make it today, because he would have given you a very nice insight about the experience from Novo Nordisk, using the model, but also contributing potentially to the community back a specific package. So I think what is really interesting from the industry's perspective is how we can identify, from having identified the number of weaknesses in the stack, organize ourselves to possibly help LinkML and work with the developers in our community to push a number of elements. So what are the next step, in a way, how we proceeded. So this is the aspect we would like to produce for each of the entities that we have a LinkML schema, generate the derivation or all the JSON schemas and LD context, so we can communicate this completely in an open fashion. Have also a number of Excel templates. This would be just using off-the-shelf LinkML platform. But also, we would like to test further the conversion. Once we retrieve the data, can we generate the from instance data the associated RDF graph that we would like to push to the respective knowledge graphs that we may have in our own organizations. And this is the kind of challenge we would like to wrestle with, to see how far we can go in these alignments. The next steps is to test, once we will have defined this concept, is to test the scenario of data exchange. So building a data dictionary, pushing that to our CROs to see how they react, or test between, let's say, AstraZeneca and Novo Nordisk, an exchange of data, and see what are the benefits of this overall framework. So with this thing, I just will stop here and just take any question. Just to mention that the project manager of the work under the Pistoia Alliance is Giovanni Nisato. So if you have any questions, you can reach out to him. And I thank you for your attention and take any questions. Thank you very much.